Okay, this is part 2 out of 2 videos for Math 31, section 7.4, congruent triangles, and now we're looking at similar triangles. Similar triangles are the same shape, and that implies that the angles have to be equal to each other, but they don't necessarily have to be the same size. In fact, usually they aren't. The side lengths, however, have to be proportional. So you see this a lot when you make a shape bigger or smaller. It doesn't even have to change actually, but you make it bigger or smaller is usually what's meant, but you don't change the shape. So I'm going to emulate that by pinching on the screen like you would on a cell phone to make that bigger or smaller. So the original is that size, and you make a bigger version of it, and now you've got a similar triangle. It's bigger than it used to be. Now I've got two triangles here that are similar. They're side by side on example 6. And what I want to show you is what's meant when it says similar. This is a 90-degree angle, or at least very close, and it would be exactly the same as that one. Then we would have this really sharp angle over here, and those would be the same. They look like they're about 20 degrees each. And then finally we have this one here, and I would guess that's about 65 degrees or something like that. So the angles actually match up pair by pair. And the way, if you're in a geometry class, to indicate that is to draw a single arc and then a double arc and then a triple arc. And the ones with the same number of arcs, for instance the two with the double arc, they are the same exact angle measure. And that one out there that I just mentioned is probably around 25 degrees, maybe 20 degrees, but it would be exactly the same as that one, whatever it is. Now the sides obviously aren't equal. For instance, if I put a congruent mark there, that would be a lie. 12 centimeters and 8 centimeters are not the same length. What you have in the case of the side lengths on a similar triangle is that the sides are proportional to each other. So what we're going to do here is they have the same ratio. Now you have to decide how you're going to do this here, and it's forgiving. I'm going to put the small triangle on the top, or in a large triangle on the bottom. You can make the other choice. You just have to be consistent. Don't change your mind halfway through if you do it the other way. Okay, so the longest side on this small triangle is the 14. And that would correspond to the longest side over here of 21. Okay, then we have the shortest side over here is 8. And that corresponds with the shortest side over here is 12. And then finally, let me pick a different color here. We have the medium side length over on the small triangle, and the medium side over here is 18. Now somebody else making the opposite choice here would simply have all these numbers. If you switch this small with large, all of these fractions would just be simply turned upside down, but it doesn't change how you do these problems. Okay, to see that these actually are equal, we're going to divide these by 6. And that gives a ratio of 2 to 3. And if you divide these by 4, you get the same ratio. And if you divide these by 7, you get the same ratio. So these are all 2/3, 2/3, and 2/3. Now in practice, when you're doing this, you usually don't use all 3 sets of sides. We're going to do that on this problem though. And this time I'm going to do the small triangle on top. Well, I did that last time, but anyway, small triangle on top and large triangle on bottom. And that's arbitrary. You can do it the other way if you prefer. And we're going to find the ratio. Okay, so on the small triangle, I'm just going to write these down here: 10, 18, and 25. And that's the side lengths there. Now I have to get these lined up here. The 10 I would describe as being the shortest of the sides, so that would go to 25. And the 18 is the medium length side. So I got to find the medium length side, and that's this 45 here. And then finally, we get the longest sides, 25 over here, and that would go with this 62.5 over there. Now we're supposed to find the ratio, and the easiest place to find it is here. Divide these both by 5, and that'll give 2/5. But just to check, let's see if dividing this by 9 gives the same amount. And you get, 2/5. And then this one here is a little harder to do. Well, first of all, multiply top and bottom by 10. And we do that to get rid of the decimal. And then these divide by 25. When you do that, actually they divide by 125, excuse me. So let me back up a little bit here. And you get 2/5 there also. Okay, so the ratio of these side lengths is 2 to 5. Okay, you can solve for a missing side if you know that they're similar to start with. I'm going to do it with the large triangle on top this time. And the small triangle, I'm going to put those side lengths on the bottom. And you just fill in the top with what you know. In the large triangle, we have a 60 and an 80. But you have to be careful once you've done that to get these lined up correctly on the next one. Do I do 45 there and X there, or do I do it the other way around? Well, look at the side and describe it. Is that the shortest length, the middle length, or the longest length? And it's the shortest. So over here, it goes with this 45. And then the 80 is the medium length side. There's actually a longer one that we don't know down there. It's not marked. But that 80 is not as long as this side down here. So we're going to go with the medium length side, 80, and the medium length side over here is X. Well, what's nice about this is you can now cross multiply. 60 times X in the downhill direction, and 45 times 80, give me a second to do this on the calculator, is 3,600. So we'll divide by 60 here to finish this job. And that gives X equals 3,600 divided by 60 would be 60. So it's 60 inches in length. Okay, here's another example of that. I'm going to put the small triangle on top. You could do it the other way. It won't make any difference. I'm going to put those side lengths on top, and the large triangle, I'm going to put them on the bottom of this proportion. And we only know 2 side lengths on each, so I'm not going to do a third pair. All right, so the small triangle has a 12 and an X. And then I have to decide which side to pair with a 12. Well, you'll notice that it's slightly longer. It's the longest side of the triangle. And from the appearance, it would be this 15 that it goes with. Corresponds with the 15. And the X is the medium side length, and that goes with 11.25. So we're just going to cross multiply here. In the uphill direction first is 15 times X. And then 12 times 11 and a quarter is 135. And we'll divide both sides by 15. And that'll take us down to 9. So that'll be 9 feet long. Okay, the last problem here in this note set, I think that's right. Yeah, the last problem here refers to a tree that I had in my backyard growing up when I grew up at the mouth of the Amazon, and this Amazon tree was really, really big. And my dad, when I was in junior high, my dad showed me how to find out how tall the tree was without actually climbing it with a tape measure. It's called indirect measurement. And the concept here is that the sun's rays come in at the same angle. So you can see me maybe highlighting that angle. You drive a stick vertically in the ground and you measure the shadow lengths of both the tree and the stick. And then this makes similar triangles here. So you're just going to set it up. This time I'm going to do large triangle on top. You can do the other way if you prefer. And the large triangle here has an X that's unknown and a 42.3 foot length. And then in the other one, we have this 10 and this 4.5. Well, if you look at the way they're situated here, the 10 goes with the X. But the other way to think of it is you want the shadow to go with the other shadow. So we're going to go 4.5 feet over here and 10 here. So downhill direction, when you're cross multiplying, gives 4.5 times X. And in the other direction, you get 423. So what we're going to do here to simplify this is just divide by 4.5. And that would cause this to cancel off and give your X. 423 divided by 4.5 is 94 feet. And that really is the height of, I figured this problem so that it would be the height of the tree that was in my backyard. Overnight, if it rained real hard, I could hear these, they have this great big fruit that grew in this tree. And when they hit the ground, if they'd fall, it would hit with a big thump, and that heavy fruit would be 4 or 5 inches embedded into the dirt. You learned real quick you didn't want to walk under that tree because it would knock your lights right out. And I think I remember there was a dead branch at the top. This vulture used to sit on it and watch me go to school every day. And not sure what that says about me, but I was young and he thought I apparently looked pretty tender because he'd sit there and give me some tender attention as I'd go to school every day. Okay, so enough of this nonsense, and I hope you learn how to set up your proportions correctly here. I think the most important thing is that you know you have to get the same triangle going across the top and then the same triangle across the bottom, and then you have to get matching descriptions going the other way before you cross multiply. Okay, so that does it for video 2 on this section 7.4 notes.